All right, hi guys. So my name is Haishal Davian, and that's Dan Akristini. And we're for a small blockchain startup based in Amsterdam. It's called Kryha. And from a day-to-day basis, what we do is we help organizations explore blockchain, and we take it from the idea phase to actual prototypes to test, and then eventually to the pilot phase. But I'm not here to talk about our company. I'm here to talk about a project that we did at the Hackathon. It's called Grex, a decentralized hive mind. So we participated in the Hackathon in April this year, where we won as well. We participated in the machine-to-machine economy track. So there were different tracks like healthcare and public safety and all of these different tracks, and we participated in machine-to-machine. And what it entails is that how do you envision a world of tomorrow and build something with the tools of today? So a world where we have basically humans liberated from performing tedious, hard, and dangerous tasks. A world where we have machines that are interacting and communicating with one another in a decentralized way. So what we came up with is Grex. Grex stands for swarm in Latin, just to put it out there. And what we presented was a fleet of machines that interact with one another and agree on a world state. So we had drones flying around. We had charging stations where drones can fly in, charge themselves, and go execute their mission that they're working on. We had like stations that are 3D printing machines, all simulated. And basically, once you connect all of these machines with one another, you create like a whole circle of their autonomous lives, where you don't need any human interaction to basically keep the system running. So I'm going to show you guys a video. Okay, so for a little bit of context before it does its action, what we have here are, it's a stupid video because we basically trashed all of the drones before filming this. So they didn't behave the way we wanted to, but what's happening is we have drones retrofitted with Raspberry Pis, where each drone is running a full blockchain node. And with this, you can basically represent the world. So whatever they observe, they report back to the blockchain. And this way, you can have all of the machines basically are up to date with what's going on. So in traditional swarm intelligence, you have machines that are only, they only know about their local environment. So they communicate with adjacent nodes or what they can observe. But what if you want to create a global intelligence? If these machines are now scouring around, doing search and rescue, or building, or wildlife protection, or planetary observation, what if you can collect all of this intelligence in a decentralized way? So this is what we did. So you have one drone that took off. You can't see it, but there's a marker below it. And that triggers the other two drones to basically launch, and then they want to align in space. We wanted to initially have them fly to the same direction, but they kept crashing into each other. So we thought, let's just make them align. So that's what the video is. All right, so my colleague is gonna basically talk about what we have been doing since the hackathon. So okay. Take it away.
Thank you. There's some echo. I hope I'm gonna try to avoid it by any chance. Okay, perfect. So the video that you saw is really simple. The thing is, the drones crashed so many times before we actually filmed it, so they would no longer go the same spot. The first one you saw, we already call it twitchy because it only goes one way no matter what happens. It's just because the gyroscope is screwed up completely. And we have this idea about a completely decentralized world that autonomous agents perform everything themselves. It's a full cycle, but to get there, we actually had, after the hackathon and everything, because the whole goal of the hackathon was what if there exists this world of tomorrow that you build with technology of today? We're like, okay, great, we built something that we can show off, but where do we start now? So for the following 1.5 to 2 months, we just took this project and we dissected it. We're like, okay, what did we actually build and where are we now? How can we go there? So we realized, great, so we built that part. That is just a world consensus, so each drone agrees on the world state. That is great. Where does it get it from? Where is the data? How do they reach agreement on who is allowed to access this network? Those are the other 3 parts. And I tend to have a problem. I really love buying domain names, especially when they're €3 a piece. So we own all of those. I do. They're registered to my name. But the idea is that it actually shows you the modularity of the system. We're not a space company. We build decentralized applications on top of existing protocols. Like the conversation that was introduced to us, we do know Dimitri de Jonge. He's a good friend of ours because we've built on BigchainDB since day 3 of launching it. I personally built before pre-alpha. So I really know their technology, and together, our devs are like, oh yeah, it's fine if it's pre-alpha. If you're okay with deploying this during 24 hours, we can build it. I'm like, okay, I won't sleep, but we did it. So that is actually what happened. So that is a peer-to-peer world consensus. Based on blockchain, we agree that this is a world state. I can only append to this data. I will not be able to delete it. If you take control of a drone or you have a malicious actor, you cannot change historical data. We don't care. And there's another cool thing about BigchainDB for that part is that it doesn't use transactions. It uses objects because it's kind of a database. So you're tracking an object through time. So in this case, it is a drone, and it is part of a class, which is the world. So you have suddenly a grid of all the drones, which you always know at all times. So that is the main element why we really thought the solution was so innovative. But before that, you need governments. Who is actually going to give you access to this data? Well, probably a DAO, probably a co-op, probably a foundation. Please tell us. We're figuring it out. We know how to build it, though. Then before that, you need somebody, you got access to the data, but where is this data? Who guarantees you that you will be able to access this data? This is why you need a decentralized access control layer. So we know how to do that, again. But the problem is, what data do you get? And this is the part where we're like, okay, we have drones, they sense stuff, great, they can check for stuff. But if you want to do this for the entire world, the main problem is that where are the regulations for drones? In each country, it is a specific issue. It is almost impossible. I mean, it's possible, but it is so big of a headache, and I don't want to deal with this, and we don't want to deal with this, so, oh, satellites. Great. It's actually an easier option if you think about it. And if you do a peer-to-peer data storage on the satellites, which you cache only a certain level of data, you don't need historical data, because if you have a relay, or I believe our colleague, future colleague potentially, let's see if it works out, but no, partner, fine, is that better? Okay, partner, future potential partner. Actually explain to us, if you have a relay and a satellite dish, you do not have to consume the entire bandwidth. So you can always keep pulling data, and you can have your own server pulling data from a decentralized system. Now you have a relay. Great. So what is the nice part? Each of these is actually part of a protocol. And we've built on each of these protocols before. So for the decentralized data storage, you need IPFS. That is actually historical. It works live. It's always there. I mean, if you have a node that pins this data, which you can actually specify, you have the data forever. And you can track its changes. It's like GitHub with uTorrents together. Next, for the market, it basically just means a decentralized consensus layer, which is Tendermint. It works really fast and it's great. And we've done it before. For foundation, oh my God. This is like, you can do it as a DAO, but you have to be registered in Zug, and there's a lot of complications with that. We are still figuring it out. But the point is, you can only contribute data to the system if you contributed hardware, software, launches, security audits, whatever. You cannot actually buy direct access to the data. But if you're a partner to this foundation, at least this is the vision that we're pushing, is that you get some tokens for building, I don't know, a small part of a satellite or launching the satellite. It can be absolutely useless to you to have a token for a data market if you build satellite hardware. Why would you? What you do in this case is you sell yours on the secondary market. One good example is if you're familiar with Ocean Protocol, that's how you could do it. You can always implement the different ways of selling secondary data for like a secondary marketplace for data. We don't know yet exactly which is the best one, but we know this one could work. And okay, fine. Afterwards, you have a world state that you've seen before. That is the big chain DB. I mean, it doesn't really show up there. And the last part is what Heishel said is the final part that we really hope to build is the federated learning using blockchain. So you can actually contribute separately to a world model which is not stored in a central database nor in a distributed database which no entity has control of. So what happens when you take three of them? So the network, which is based on IPFS, the market, which is based on Tendermint, and the foundation, which can be a DAO, which can be Ocean, pick yours. Well, you buy another domain name. So I mean, come on, it was only €3. So we're like, okay, now we can apply this to a real situation. So we're like, can we do this with satellites? We're a blockchain company. We love building centralized applications. We don't know how to do this exactly. We know we can support somebody who's building on this already. So problem, yeah, the access to space data. We really need geodata for this, but we want it in a decentralized manner. We don't want the central exchange because that creates a single point. And we don't like centralized systems. It's really not our thing. And yeah, we saw that data space is expensive, but there are alternatives. I think somebody here suggested to me the Copernicus project, which also gives you free data. But again, that is from a centralized party. And it's like you're getting the rest of the data that was not in the intended use of this mission. It might not even be as up to date as you want, so not with the same data rate. And yeah, space debris is a thing. This is an exaggeration, but each of these points are actually there. It's just, it really shows you what's the debris in the low Earth orbit. And our system is really a decentralized data marketplace. Why would you launch another satellite if you can just collaborate and use a part of the network? I mean, to us it seems really simple. And yeah, that's a real deal of low Earth orbit space debris. Have fun, because we really love space. We really want to be able to travel there one day. We want to be able to launch stuff there. And if you have to calculate collisions, that's not the best use of your time, I think. Yes, so just a couple of bullet points on why this is why we like it. So tell us if we're wrong. We're really curious. But low Earth orbit is decentralized by nature, because if you want to have an always-on system in that part, you need to have at least 50, I think 66 is what the Iridium satellite network is, to have global coverage at all times. And access control managed on the satellites themselves, I mean, now you suddenly don't need basically the latency involved to ask another party to get access to the network. So you just get access yourself by having pre-approved sessions. Yeah, pre-approved sessions. Oh yeah, and because we use a blockchain consensus algorithm, so we know who is allowed to access the satellites. If suddenly the satellite you are querying goes out of your line of sight, or I don't know what's the technical term, you can query the next one because it already knows you're pre-approved. It's fine, great. LEO-oriented, yeah, if something goes wrong, replace it. And to my knowledge and to what we've figured out in the meantime, because again, we're not a space company, remote Earth sensing is performed in low Earth orbit. I mean, for a lot of use cases. So a lot of people really want to use this particular orbit. Yeah, we want the data sharing platform, incentivize everybody to collaborate. It's not an ICO, sorry. And yeah, so that's, I mean, this is just our idea right now. If you want if you really want access to the data, you have to contribute with hardware or software or whatever. And then, if you're a partner to the system, you can sell the tokens themselves. So you can share your share of the access to the data. Why we really thought this would be cool is because now we suddenly don't have to perform KYC. So suddenly the partners themselves have to perform it. So something easier for us, something we don't want to do, something we're not good at, we suddenly give it to participating partners which might actually be interested in performing this action themselves for getting money. If you have questions, please do so. My end thought, I think, is we're a blockchain company. We've been doing this project because we've been tasked to do it for a hackathon, and we thought it was really cool. But now we end up at a after the hackathon, and we're like, okay, what do we do now? How do we do it? Oh, it's applicable to space. We got invited here. Is this relevant to you? Is anybody actually interested in getting this further? Because we're really up to partnering up and pushing this further because we have actual building blocks available at a POC level, but should we continue? Why? Yes, please talk to us. And I don't know if this works. I am on 3 hours of sleep, so if I throw something, it might end up completely wrong. And Heischel is also available for the Q&A, please.
That's why you need to throw it.
Energy. Kinetic energy transforms into like, no, what?
One. Wow. Have you tried adapting this to any other any other systems? Not just, I mean, not just the drone systems or the satellites. This, the way the stuff you're describing would actually fit really well for a decentralized distributed manufacturing system, where you could actually do, small automated, distributed automated factories, which could do manufacturing of infrastructure. I want to talk to you later about this.
Yeah, sure, great. What we didn't think about this one specifically. I mean, it's a very specific use case, so it wasn't. But we were like, okay, if this makes sense for this situation, we could also apply it, for example, for autonomous cars or for something. Because again, it's an actual swarm. So okay, if you're really seeing elements of this that interest you, yeah, let's talk.
Perfect. Oops. I think this is really cool, by the way.
Happy to hear.
Question from technical point of view. Where do you see yourself having the connectivity point from? Are you thinking of satellite connectivities to each of these nodes, or are you thinking more like 5G, 3G cell connectivity?
Okay, so the idea for the consensus is by design originally, without hearing the CubeSat lesson, was that there is currently technology regarding laser satellites, and they have a peer-to-peer communication system in space. So that's why for us this was the most important layer, because once we establish consensus between satellites, then we can just use relays to connect to them, because we always want to have consensus up in space.
Cool. So I'll speak to you later.
So it would be, just quickly to add, so you'd probably have lasers or high frequency there, and then, I don't know, normal, you explained it last time, some type X band, I think.
Yeah, well, I show you the data rate that you have. Can you work with that? Or do you need something which is...
That's fine. That is actually 100 megabit is great.
How about 10?
Fine. Lower than that, then you have really, really bad images unless you're working on really specific remote sensing data, such as temperature, I don't know, like pressure systems, because that is just strings, so we can always save that. It's a JSON file. We don't need too much. If you're doing images, that is when bandwidth really matters. Okay, great. Thank you very much.